of the Cybercab line, it doesn't look like a normal car manufacturing line. It looks like a really high-speed consumer electronics line. It's, in fact, the line will move so fast that, that actually people can't even get close to it.
Tesla just shocked the entire automotive world by purchasing the most insane Gigapress machine ever created that will allow it to build the complete underbody of its affordable car, the Tesla Model Q, in record option time. Here's what Elon Musk revealed about the absolutely mind-blowing madness of this revolutionary machine. Like real fast? And then, I guess maybe we need to just get even bigger casting machines. Sure, why not? You know, down. Yeah, let's go 50,000 tons. A massive die-casting machine the size of a house capable of producing a brand new Tesla every 5 seconds. Sounds like pure science fiction. It's not. This is the absolutely game-changing version of the Gigapress that's about to transform everything.
I think it'll be able to produce a car ultimately in less than 5 seconds. Like, can you imagine a car coming off the line in less than 5 seconds? That's like, whoa.
Something Elon Musk described as a giant version of a toy factory, but with jaw-dropping power that completely destroys imagination. This machine doesn't just cast one part at a time. It can simultaneously mold 5 vehicle underbodies with unbelievable precision that will blow your mind. Tesla is the first electric vehicle manufacturer in the world to apply this breakthrough gigacasting technology to mass production at this scale.
So I mean, we got to jam the liquid metal in, cool it down real fast, like real fast.
While competitors are still desperately struggling with traditional assembly lines, Tesla has taken a massive leap by integrating these revolutionary Gigapress machines into its smart manufacturing system, and it keeps improving at lightning speed. It all started with the incredible 6,000-ton Gigapress used for the Model Y, which replaced over 70 separate parts with a single aluminum piece in one shot, dramatically cutting production time, slashing costs, and boosting precision to astronomical levels. Then came the absolutely powerful 9,000-ton Gigapress. So powerful, it can form the complete underbody of the Cybertruck, one of the most advanced chassis in the entire EV world. But Tesla's unstoppable ambition doesn't stop there. The upcoming 50,000-ton Gigapress is set to accomplish something no previous Gigapress has ever achieved before. So why is such an enormous pressing force absolutely necessary? And how can a single machine produce 5 complete vehicle frames at the exact same time? Let's dive deep and discover the shocking truth that will change everything. Welcome to Auto Intel, your ultimate source for cutting-edge automotive technology and Tesla secrets. Before we explore this mind-blowing EV manufacturing technology, let's travel back to the beginning where the revolutionary concept of the Gigapress was actually born. This isn't your typical average machine. The Gigapress is a high-pressure die-casting machine developed by Italian company Hydra, which is now part of the powerful LK Machinery Group. Few people actually know that this world-changing revolutionary idea began with a simple everyday moment. Elon Musk, while holding a die-cast toy car at his desk, suddenly asked himself the question that would change everything. Why can't we do the exact same with real cars? What started as a seemingly wild question led Musk to envision a completely new direction for the entire auto industry. Instead of assembling hundreds of stamped steel parts using traditional welding robots, why not cast the entire car underbody as a single solid piece of aluminum? At the time, Tesla was desperately struggling with intense pressure to ramp up production of the Model Y, the company's best-selling vehicle. The massive challenge was to dramatically speed up manufacturing while absolutely slashing costs. The Gigapress became the ultimate game-changing strategic solution. According to industry estimates, replacing a traditional multi-part underbody structure with a single cast piece has cut production costs by an incredible 20 to 40% per vehicle frame. But the road to turning this bold revolutionary idea into reality was far from smooth. Elon Musk reached out to the 6 largest die-casting machine manufacturers in the world to request the creation of a massive high-pressure casting machine. The shocking result? 5 companies said absolutely no. They dismissed the idea as completely crazy, unrealistic, and far beyond the technical standards of the automotive industry at the time. In the end, only one company was willing to take the massive risk: Yedra. Even then, they weren't entirely confident. At first, everything was just a maybe. But after nearly a year of intense collaboration with Tesla, Yedra succeeded in building the world's first revolutionary Gigapress. As we mentioned earlier, Gigapress machines are now used to manufacture large vehicle components, especially the underbodies of models like the Model Y and the Cybertruck, using incredible forces of Cayenne. 6,100 tons and 9,200 tons respectively. The operating principle of the Gigapress starts with melting an aluminum alloy at extremely high temperatures in a specialized furnace. The molten aluminum is then injected into a precision metal mold shaped exactly like the component being produced. For example, a complete car's underbody frame. The Gigapress applies extremely high pressure to ensure the molten aluminum fills every tiny detail of the mold perfectly, leaving absolutely no defects whatsoever. Once cast, the part is evenly cooled, causing the aluminum alloy to solidify into its final perfect shape. This process requires extreme precision. If it's too fast, air bubbles can form. If too slow, the aluminum may start to cool before the mold is completely filled. Cooling is carefully controlled through a uniform cooling system, helping the final part achieve incredible high strength and dimensional accuracy. After cooling, a specialized robot removes the part from the mold, trims any excess material, and sends it through a rigorous quality inspection process. It may sound incredibly complex, but in reality, the entire process happens at lightning speed. The advantages of vehicle frames cast by the revolutionary Gigapress are absolutely significant. By casting a single large piece instead of welding together dozens of smaller parts, Tesla reduces overall vehicle weight, increases structural rigidity, and boosts performance dramatically while saving time and labor on the production line. Beyond Tesla, other major automakers like General Motors, Hyundai, Volvo, Zeekr, and EC have also invested heavily in this cutting-edge technology. Notably, XPeng is committed to a massive 16,000-ton Gigapress. However, Tesla remains the first and, so far, the only company bold enough to push the absolute limits with a mind-blowing 50,000-ton Gigapress. Why does Tesla desperately need a 50,000-ton Gigapress? Producing the Model Y's rear chassis using the 6,000-ton Gigapress has allowed Tesla to cut manufacturing costs by up to 40% by replacing around 70 separate parts with 2 larger castings and a structural battery pack. So, it's absolutely no surprise that Tesla is looking to replicate this incredible. The new car is even smaller than the Model 3, with a design that features very short front and rear quarters and virtually no trunk space, making it the perfect ideal candidate to test the revolutionary idea of die casting a single-piece rear chassis. But no matter how small the car is, the 6,000-ton press used for the Model Y isn't nearly powerful enough to cast the entire chassis at once, as it can currently only cast the rear chassis. So Tesla used a much larger gigacasting machine to produce this absolutely game-changing low-cost car called the Model Q. Not only does it allow for the entire chassis to be produced in one single casting, but the Gigapress can also cast 5 chassis of this model in one revolutionary casting cycle. The design of the Cybercab line, it doesn't look like a normal car manufacturing line. It looks like a really high-speed consumer electronics line. It's in fact, the line will move so fast that actually people can't even get close to it. When Elon Musk first mentioned the incredible 50,000-ton Gigapress, the first question we asked wasn't, is it even possible, but rather, how absolutely massive is it going to be? Where would such a colossal machine even be placed? How long would it take to install? And how could it possibly cast 5 entire underbodies at once? Well, this is no ordinary machine. According to Elon Musk, the new production line using this machine will operate at a speed so incredibly fast that humans won't even be able to get near it. The entire process from pouring molten metal to high-pressure casting, mold cooling, and part removal will be handled entirely by robots in advanced automation. No workers standing nearby to inspect, no one manually adjusting parts. Everything will be synchronized in a fully closed-loop system where each press cycle takes only about 5 seconds. In other words, within just a few blinks of an eye, a complete one-piece EV frame will be finished and ready to move on to final assembly. You could imagine that with a 50,000-ton Gigapress, it could easily be as large as a 3- or 4-story building laid completely on its side. Tesla may need to construct a dedicated facility just to house it, possibly with a specially reinforced concrete foundation several meters deep to support the absolutely immense weight. Compared to the existing machines like the 6,000-ton and 9,000-ton Gigapresses, this new machine delivers roughly 8, 3 times and 5 times more pressing force respectively. While the size, clamping force, and number of molds differ dramatically, the operating mechanism of the 50,000-ton Gigapress isn't fundamentally different from the 6,000 or 9,000-ton models. It all still starts with precise material preparation. Tesla melts down new aluminum ingots along with leftover aluminum from previous castings in a furnace heated to around 850 Celsius or 1,562 Fahrenheit. Then any surface impurities are completely removed before the molten metal is transferred through heated pipes into a sealed holding furnace, maintaining a temperature between 1,382 Fahrenheit to 1,562 Fahrenheit. From what we know, the Gigapress uses a dual furnace system to process the aluminum alloy. One furnace acts as the melting furnace, powered by natural gas and operating in around 1,562 Fahrenheit. The other serves as a holding furnace, electrically heated and maintaining a temperature between 1,382 Fahrenheit and 1,562 Fahrenheit. As previously mentioned, inside the holding furnace where the molten aluminum is stored, the empty space is filled with nitrogen gas. This is absolutely no coincidence. Nitrogen acts as an invisible protective layer, preventing the aluminum from coming into contact with outside air and thus avoiding oxidation. At the same time, it helps maintain a stable temperature, keeping the metal in a ready-to-cast state. But nitrogen alone isn't enough to achieve optimal casting quality. Tesla also uses argon gas in combination with a rotary degassing unit, a device that stirs the molten alloy and drives gas bubbles and impurities to the surface. After that, a specialized silicon carbide filter removes particles larger than 25 microns, ensuring the alloy is clean and uniform before it enters the mold. This is the material refinement stage, an extremely important step to ensure the quality of the final cast product. This is the material refinement stage, a critical step in ensuring the quality of the final cast product. Once the material is ready, the next step is mold preparation. And the Gigapress handles this with near-perfect precision. Before each casting cycle, a specialized robot sprays about 35 ml of soybean oil in a thin, even layer across the mold surface. It's a bit like non-stick coating in cooking. This helps the cast parts release cleanly from the mold without warping or surface defects. Immediately afterward, the system creates a vacuum inside the mold cavity, removing any remaining air to ensure the molten aluminum fills the mold completely without trapped gas or bubbles. Once everything is perfectly aligned, the molten aluminum is transferred from the holding furnace into the Gigapress's injection chamber. There, a high-speed piston injects the alloy into the mold at extremely high pressure. To ensure smooth operation, the piston itself is lubricated with about 8 ml of oil before each injection. Everything happens in just a matter of seconds, but every detail plays a crucial role in producing a one-piece EV frame with micrometer level precision. Within a single casting machine, we could do like 5 at a time or something, Trying to think like how do you scale castings because you got liquid metal, metal's got to cool. And you've got to automate, getting all the bits and pieces off the casting so it's usable. When the molten aluminum is injected into the mold, solidification doesn't happen instantly. The alloy needs to remain inside the mold for a few seconds to begin the crystallization process. Once the material is solid enough, the entire underbody frame is ejected from the mold at a temperature of around 400 Celsius or 752 Fahrenheit. Still extremely hot compared to ambient conditions. Immediately afterward, the cast part is transferred to a cooling bath where the temperature rapidly drops to around 50 Celsius or 122 Fahrenheit in just a few dozen seconds. Rapid cooling isn't just about lowering the temperature. It also serves an important technical purpose, improving the alloy's crystal structure, eliminating defects formed during solidification, and enhancing the mechanical strength of the entire underbody frame. So, we got to jam the liquid metal in, cool it down real fast, like real fast. Meanwhile, the mold after releasing the cast part is cooled down to around 185 Celsius or 365 Fahrenheit, a temperature low enough to stabilize heat levels without P. Affecting the next casting cycle. A specialized robotic system then thoroughly cleans the mold surface, removing any leftover material residue and excess lubricant. Thanks to the incredible speed and precision of the entire system, a new casting cycle can begin just 1 to 2 minutes after the previous one ends. Any excess metal, such as flash, rudders, or leftover sprues, is automatically trimmed and recycled back into the melting furnace for future cycles, ensuring virtually zero material waste. To make sure every product meets strict quality standards, an industrial X-ray imaging system is deployed directly on site. Each vehicle frame is scanned to detect microscopic defects such as gas porosity or internal cracks that can't be seen with the naked eye. This is a critical step in ensuring structural integrity, especially important since this cast frame serves as the primary load-bearing foundation of the entire vehicle. And finally, to withstand the immense pressure of injecting molten alloy in high speed, the Gigapress must maintain an extremely powerful clamping force to keep the mold tightly sealed, preventing cracks, warping, or leaks. With the 50,000-ton Gigapress, this clamping force ranks among the strongest ever used in the automotive industry. According to Elon Musk, achieving the incredible speed and precision of the 50,000-ton Gigapress required Tesla to develop a series of groundbreaking innovations never before seen in the auto industry. First is an ultra-fast cooling system custom designed to rapidly cool massive cast components in record time without compromising the metal's structural integrity. Second is an intelligent mold release mechanism that allows parts to separate from the mold smoothly and precisely with no manual intervention required. But the biggest breakthrough lies in the AI-integrated automated quality inspection system. From analyzing X-ray images to evaluating real-time data from thermal and pressure sensors, this system can detect potential flaws with high accuracy, completely eliminating the need for human visual barrel checks. This represents a major leap forward compared to previous generations of Gigapresses such as those used for the Model Y and Cybertruck, which were already highly advanced but still hadn't reached the deep intelligent level of automation seen in the 50,000-ton Gigapress. More importantly, the fusion of robotics, artificial intelligence, and precision engineering has brought Tesla closer to a production model that closely resembles the electronics industry. Ultra-high-speed, hyper-streamlined processes, factory floor space optimized down to the square meter, and near-zero variation between repeated products. As we mentioned earlier, Tesla needs to replicate the efficiency of the Gigapress for the Model Q, and this compact hatchback is seen as the most ideal candidate for fully casting its underbody using the Pratsa 50,000-ton Gigapress. The reason goes beyond just aiming for massive production volumes. It lies in the design philosophy and industrial strategy behind this vehicle. First and foremost, the Model Q is positioned as a global, affordable EV, targeting the mass market with an estimated production volume of millions of units per year. At such a massive scale, streamlining the production line becomes a matter of survival. Casting the entire underbody in a single press cycle drastically shortens production time, reduces labor costs, minimizes the number of welding robots needed, and optimizes factory floor space, perfectly aligning with Elon Musk's matchbox manufacturing philosophy. And that's kind of how they do it in small volume castings. They'll do have a casting block that'll make 100 matchbox cars at a time. We just make that real big. Yeah. I mean, we have the cathedral casting back there. The Model Q features a compact and simple design without the complex curves or multi-layered structures seen in the Model Y or Model 3. This structure is ideal for casting the entire underbody as a single piece in a short amount of time, what Musk described as just 5 seconds. I think it'll be able to produce a car ultimately in less than 5 seconds. Can you imagine a car coming off the line in less than 5 seconds? That's whoa. It may sound like science fiction, but in reality, with an optimized structure like the Model Q, Tesla can completely press out the entire chassis in just one pressing cycle, lasting less than 5 seconds, not counting the next assembly steps that are fully automated by AI robots, aligned so fast that humans cannot get close. If this becomes a reality, Tesla is not only speeding up production, it is redefining the limits of global industrial manufacturing capabilities. Please share your opinion in the comments section below this video. Thanks for watching our video. If you want to explore more exciting information about Tesla EV or Tesla Bot, don't forget to hit the like button and share this video. Also, make sure to subscribe to Auto Intel and turn on notifications so you never miss our latest videos. We're almost at 1,000 subscribers, and your support is what makes this incredible journey possible. We appreciate your support and look forward to seeing you in the next video. Goodbye!